Welcome back to the course, friends. In this one, miscellaneous examples of finding limits at infinity. So here's our question. F of x, say, is defined as cosine of x this time, and it's over 1 plus x. What we want to know is the limit as x approaches positive infinity here of this expression right here. Cosine x over 1 plus x. How can we do this? It really does help if you have an understanding of the basic cosine function and you realize that its maximum value is 1. And you realize that 1 plus x as x goes to infinity, 1 plus x, that part also gets ever bigger. For example, when x is a million, 1 plus a million is a huge number, right? The maximum value of the cosine function, though, is 1. So take a look at this picture here. It will help us to understand things better. So graph cosine by itself, and then graph here 1 plus x by itself. You want to look at the relative strengths of the two functions. In other words, compare them to each other. So I'm going to kind of scrunch over it this way. And as you can tell, the maximum value of the cosine function is 1, about right there. And it never gets beyond 1, in other words. Whereas the green curve, which represents 1 plus x, goes to infinity, and it gets ever bigger, 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 and bigger. So to find the limit then, as x goes to infinity, of cosine x over 1 plus x, you can just write instead the simpler form. Limit as x goes to positive infinity. And just in the top, put a 1 because it's the maximum value of the cosine function, like this. And this is then 1 plus x. From here, as you've learned previously in our other videos, 1 relative to x is insignificant. You can drop it, the 1 in the bottom, that is. So you have the limit as x goes to positive infinity of just 1 over x. And of course, we've studied this one extensively already. This is equal to 1 over infinity, roughly speaking. So in other words, some people will write it this way. They'll kind of put infinity this way, even though that's not official math, because remember, infinity is not a number, it's a concept, so you can't actually divide by it. But it gets the idea across, which then of course is that this is 0 in the end. During these operations, again, if you have trouble understanding what's happening, take a look. Graph the original cosine x in its original form, divided by 1 plus x. You see, this looks like this. Now you just have to scrunch this over, in my case, because you're looking at what happens when x is big. And then plot, for example, just 1 over 1 plus x, the next step. And you see the behavior out here for large values of x, say here, and then here, and then here, and then here. This behavior is about the same. You can't really differentiate them very much anymore. And lastly, if you graph the last one, which is just 1 over x, which we got from it, notice that the behavior of that red curve is about the same as the other two when x is large. That's why this is allowed. Obviously, to stress this point, around 0, the behavior of the cosine x over 1 plus x, and then 1 over 1 plus x, and then 1 over x by itself, the behaviors of those three objects are very different. You see that there in the black box on the left side along the vertical axis. Let's move on. Another possibility to be considered might be this one. Now here, if you do make a graph, what information does the graph provide and how do you interpret this information? So, as you can see, it looks like this. So scrunch this over. You always want to look at large values of x, because that is what we're studying, right? Limits at infinity. So large values of x. Now in this case, unfortunately, this pattern of bouncing up and down because it's a cosine function, it just never stops. So what do you write here? Some people will write, for example, that it oscillates. Well, that is true, the function oscillates. But remember that a limit is supposed to be a value that the outputs approach. There is no such value that the outputs approach. No settled value, that is. Look, if I do cosine of something big already, like 1,000, and punch this in to a calculator, I get a 0.56 as my output. Do a cosine here of, say, something huge. Well, that's not too huge, but it's doable there in the calculator. That's negative 0.95. So it goes from positive to negative. Cosine, say, of something much bigger still. Punch that into your calculator. It's back to 0.94. It's not settling down to just one value. In other words, what is this telling us right here? These outputs are suggesting something important we've got to know. These never settle down to one specific value. Compare this with the following calculations that we've already done in this course. 1 over x. If you calculate 1 over 10, that's 0.1. If you calculate 1 over 100, that's 0.01. If you calculate, for example here, 1 over 1,000, that's 0.001. There's a clear pattern that emerges pretty quickly. 0.1, 0.01, 0.001, those values are clearly, in other words, like this, right? These are approaching 0. Not the case for the cosine function. So the answer therefore here is that the cosine in the limit as x goes to infinity, that limit is d and e. It does not exist. Not that it oscillates up and down, there's something else that doesn't exist. This is another famous one. So the limit, say, as x approaches negative infinity, this time say of the sine function, so sine of x. Same reasoning applies. You can sketch it first or graph it. You kind of study the behavior using a graph. Alright, now you have to scrunch this the right way. Remember that our x is going towards negative infinity. So I have to scrunch this the right way. Let's see, like this. And move it over this way. I'm going to scrunch it a little bit more. Give me 1 second here, and then move it over this way. Same principle. You see, when x is going towards negative infinity this way, right, the values of the function, they seem to oscillate. They oscillate specifically between, as you can see, positive 1 and negative 1. But remember that when we talk about limits, what we are saying is that the values approach some specific value and they settle down to it. That's not the case here. Take a look. Do sine, say, of negative, let's make it just big in the first place, negative 10,000. Punch this into your calculator, immediately it gives you 0.31. Exaggerated still. Sine of negative, add a lot of zeros in there, so you're very far to the left of 0. Oh look, it's 0.35. It's kind of going up. Let's do one more time. Sine of the following, negative. Let's make it kind of big. Add some variety. Negative 0.42. Now it's negative suddenly. So it goes positive, a little bit more positive, then suddenly it's negative at this much bigger value here. That is an absolute value that would be bigger, right? But it's more negative. Remember, more negative actually means smaller, mathematically, strictly speaking. So the point is that all of these calculations suggest something. Again, what's the idea? What's the pattern? These don't settle down to any particular value. Because that's the case, to answer this question, in other words, you would say that the answer is D and E. Does not exist. So these are some additional examples of looking at limits as x goes towards positive or negative infinity. Thank you, friends. I'll see you next video.